Hello, everyone. I'm Mateusz Barteszko from Adaptive Vision. Uh, and today I'm going to show you that it's not that hard to create a 3D quality inspection application in Adaptive Vision Studio. Uh, in recent years, I've met many engineers who are, in my opinion, experts in 2D, traditional 2D machine vision, but they were somehow afraid to start using 3D in their projects. Um, Therefore, I decided to prepare this presentation and webinar and show you that it's not that hard. It's actually very similar to 2D approach, and if you understand a few differences, there's actually no difference for you. So I will start with a short introduction for those of you who haven't had any opportunity to work with 3D data so far, including data acquisition. I will mention about the supported devices, what kind of data these devices can return, how to combine 2D data with 3D data, and later on, I will show you an example. It's gonna be an application for chocolate cookies inspection. 2D machine vision has proved its has proved many times in recent decades that it's very useful for many applications and for many problems. And now we can also benefit from 3D machine vision that allows us for thickness and height measurements, volume measurements. It also helps in detection of surface defects that are not well visible in 2D because of a low contrast or an irregular surface, so that it's the lighting challenge selection is challenging. 3D is also very useful for the robot guidance and for measurements. If you want to measure an entire object, including holes and curves, as well as perform measurements along object cross section. 3D allows for this, and in my opinion, the big advantage of 3D is a simple setup, and people are usually surprised when I mention about this. But yeah, I do believe that the setup is very simple, especially if you use one of the products available on the market. There are many 3D scanners available on the market that you just need to plug in, use a filter, a function for data acquisition that is available in Adaptive Vision Studio. And that's it. You can start right away. You don't have to take care about illumination, about optics, about cameras, because these scanners have all that stuff built in, so that you just plug in a scanner and start using it right away. Adaptive Vision Studio supports some vendor-specific APIs like Gocator, Foxy 3D from Photoneo, Echo Series from SmartRay, and sensor scanners, IFM time of flight sensors, as well as many sensors that are GigaVision and GenieCam compliant, because Adaptive Vision Studio is GigaVision and GenieCam GenTL compliant. So Here we have data acquisition. You just need to use a scanner. Of course, you can still create your own algorithm that generates 3D. You can buy a camera, buy a laser, and create your generate a point cloud based on laser triangulation. But it's easier to buy a ready-for-use, out-of-the-shelf product that is pre-calibrated, and you can start using it right away. All right, so the first data type that can be acquired from 3D scanners is profile. Profile represents a cross section of an object, and it is actually it is available when you use a 3D scanner that is based on triangulation, laser triangulation technique. So then you have a profile, you can perform measurements on it because we have tools for profile measurements. Yeah, and you can measure a one cross section of your object. Another data type is a height map, and this is actually an image where the values of pixels describe the height of individual points in the point cloud. So this is actually a point cloud, but represented as in the form of image. And finally, point clouds that can be divided into two types. One are point clouds that are not organized. We have an array of points, and we just know their coordinates. We don't know what neighbors individual point has, and on the other hand, we have organized point clouds where all the points are described in a grid structure, so that we not only know the coordinates of individual points, but we also know their neighborhood. What points are they in their neighborhood? And thanks to that, the algorithms are much more optimized. Algorithms for 3D data processing of such point clouds are much more optimized, and it's easier to work with such point clouds. Moreover, such organized point clouds allows for using intensity image, because many products available on the market generates a point cloud along with intensity image, where the pixels correspond to individual points in a point cloud. That way, you can perform, let's say, you can find an alignment on this image and then use this alignment in a point cloud, or you can perform some measurements here. Let's say find a mass center of a product like this circular region, and then convert this mass center from 2D from 3D to 2D, and in that way you can create and you can combine many tools and create a very reliable algorithm. Perfect. So let's move on. Let's have a look at the example that I've prepared for you. It's gonna be chocolate cookies inspection application. So I'm opening Adaptive Vision Studio. This is our environment. I hope that most of you have already seen it. And I will start with data acquisition. As I don't want to promote any of hardware manufacturers, because Adaptive Vision is adaptable and work with a wide range of products available on the market. I will work with point clouds that I saved in files. So they are, first of all, I will use a filter enumerate files. So I'm dragging this filter from the toolbox, dropping it here, and my files in the directory surfaces. Okay, there are 7 files, and now I will use a filter that will load my point cloud, because it's saved in Adaptive Vision AV data type. So that we have a point cloud. You can see that it's a box of cookies, and our task for today is to count the cookies. So in the first step, we'll perform a segmentation of cookies. Then we'll measure the minimal point. We'll measure the minimal point of the surface, so that we will be able to detect such defects where because when the cookies are put in the box, they can be damaged. Sometimes they are broken, and then their height is not okay. So we need to find such defects, as well as we need to measure their width, because it's visible on this image. You can see that some samples, like this one, are not are smaller than others. This is not a big problem, because if the weight of entire box is okay, the manufacturer can accept that. But this is such a defect indicate that something is wrong with a production process, and the maintenance team have to take a look at the machine that forms the cookies. So the customer also wanted to detect such, to measure the cookies, to predict such situations. All right, so let's start. First of all, do you remember when I was explaining that there are 2 types of point clouds? And here we have an organized point cloud. You can see that the points are uniformly distributed along both axes. So thanks to that, they can be easily converted from a point cloud to a height map image. And then on the height map image, we can use traditional machine vision algorithm, for instance, for segmentation. It also can be done on 3D, but today I would like to show you that you can mix all the tools, and you can mix 2D and 3D techniques to achieve your goal. Okay, so let's start. I will go to the toolbox. And first of all, I will use a filter, because each block that is in the program editor is called a filter. I will use a filter that converts a surface into a height map image. So I'm connecting my input surface with the create image from surface filter. And now if I display an image, you can see it's hardly visible, but you can see that this is hardly visible because the values of pixels correspond to the height of cookies. So let's say that the average height is around 20, and let's check the intensity. Yeah, it's correct. So thanks to that, we have, thanks to using the create image from surface filter, we have height map image, and we can perform the segmentation on it. For this purpose, like I already mentioned, I will use traditional 2D algorithm. So I go to the computer vision category, and there is a segment image where extract blobs filter is available. So I'm connecting my, let's name it height map image with my surface, with my extract blobs filter, so that if I execute the filter, you can see that we have an empty array of blobs. I will switch off the preview of the point cloud. You can see that we have empty array of blobs. This is because we need to adjust the parameter. I will change the threshold values here so that the output blobs will represent the points that are higher than 1 and smaller than 25. In that way, we have an array of over 1,000 blobs, but it's not a big deal because there's a lot of noise in the point cloud, like here. So we can easily remove this by, for instance, morphological operations, so that I will open it with radius 5 and close it. You can see that we've removed many blobs corresponding to noise from the image. And I will also specify the minimum area because you can see that, let's say, 21st object has an area around 300,000 square pixels. So I will set the minimum area to 200,000. Thanks to that, we have an array of regions corresponding to our cookies. Now we can use this array to crop these regions, because if I display a point cloud right now, I can display these blobs on it. So I will crop these regions from the surface so that the points corresponding to the plastic box will be removed. To do this, I just need to go to the computer vision 3D and find a filter which is called crop surface to region. But before I will execute it, I need to merge my array, my blobs, into one region, because here I have an array of 12 regions. Now I would like to merge it into one region and crop a surface once, not 12 times. So it's easy. I just need to go to region analysis category, and there is combine region tool, and I will choose region union of array filter. So now if I connect in array with blobs and out region with in region of crop surface filter, you can see that first of all, here we have, instead of an array of regions, we have a one single region. And moreover, we have an output. You can see the output array. I will call it cropped surface. And this cropped surface doesn't contain the points corresponding to the background. So that if I remove the blue point cloud, you can see that we have a very nice looking point cloud, and we can start and we can move on and start working on further steps. But before that, I will extract a macro filter. It's a sub program. For that, I will call segment and count cookies. And this macro filter, we have an input in expected cookie count of integer data type. Perfect. And I will create a formula here that will check whether the number of blobs is equal to the input of the function of the macro filter. So I'm adding a formula block here. I will call the output is count. Okay. So let me also label this output cookies cookie blobs. And now inside the formula, I can create the following formula block. I can create the following formula. If cookie blobs count, so if the number of cookies is equal to expected cookie count, then true. Otherwise, false. All right. And I'm creating outputs of the macro filter of the same name. Cropped surface and cookie blobs. Thanks to that, now we have a function. We have a function that checks whether the number of cookies is okay. Currently, the expected cookie count is equal to 0, so we have false result, but let's set it to 12. And the result is true. Let's check another point cloud. The result is false, as we expected. How about this one? It's true. So now we have a tool, our own function, our own, we call it macro filter, that has the following inputs and the following outputs. All right, perfect. So let's move on. Let's now focus on the algorithm that will measure the height of individual cookies. And for this purpose, I will again use blob analysis technique to specify the region of interest, and the measurement will be performed on 3D. So first of all, I go to I go to region morphology, and I will use a tool for erosion. So I will shrink the regions corresponding to my cookies. Why I need to do this? I need to do this because we want to know the height of a cookie, but you can see that there are some points representing side walls of them, and I will shrink the region so that the algorithm will analyze only the interior area, this area of each cookie. So let me set the radius, and now let's find a tool that extract a minimal point of our surface. All right, so we have a cropped surface here. We have region of interest, and we have an array of points. So that if I rearrange the preview and display the height, the minimal points coordinates, you can see that most of them are around 18, 19, but there is one point that is lower, and this is this one. This is this damaged sample. Let's check the other samples. Here we go. You can see that this one is damaged, and now we could create the same formula as we did in the segment and count cookies macro filter. So we've accomplished the second goal, and now let's move on and perform measurements. Check the dimension of each cookie along vertical and horizontal axis. So let me create a macro filter, which I will call find cookie minimal point. Perfect. And now let's create an algorithm that will measure the width and height, the dimensions along x and y axis of major and minor axis of each cookie. For this purpose, I will use 2D data. We have our array of blobs, and based on the bounding rectangle of each blob, bounding rectangle, I can extract the bounding rectangle by using region bounding rectangle filter. Based on using this filter, we can get an array of bounding rectangles. You can see that the rectangle describes the anchor point, is described by an anchor point, angle, width, and height. So thanks to that, we can now create a local coordinate system that is anchored in the top left corner of each cookie. And now we can use this coordinate system as an alignment for further steps. So we have this coordinate system, and now, but it's a coordinate system in an image. We need to convert it to our surface coordinate system, to our point cloud coordinate system. And for this purpose, I will use a filter which is called Convert Coordinate System 2D to 3D. And now we have a local alignment of each cookie, and we can use a tool for width measurements. And this tool is available in Computer Vision 3D, FitShape 3D, and there is Measure Object Width. So this filter measures the width of an object using stripe detection. I need to connect the input surface, so it's the cropped one, and connect coordinate system so that this tool, you can see the square brackets here, so it means that it will be executed in array mode for individual cookies. If I turn off the scan field editor, you can see that I have a coordinate system anchored in top left corner. I just need to specify the scan field so that here the tool will perform a series of scannings along such segments, fit segments to both sides and parallel segments, and measure distance between them. All right, I will adjust a few parameters. For instance, I will increase the number of scannings to 20, so that the measurement will be more accurate. And now, if I displayed out segment 1 and out segment 2, you can see that side walls are detected, that the edges of individual points are detected. And now I can display the width of individual cookies. The width is a distance between parallel segments detected by Measure Object Width filter. Perfect. So it's almost done, but we also need to measure. Let's say it's a vertical dimension, and now let's measure the horizontal dimension. All right, so I copied the filter, and now I will edit the scanning field so that the horizontal dimension will be calculated. Let's have a look at the results. You can see that left side walls are detected. Right side walls are detected as well. So let's check let's name it horizontal dimension and check the horizontal dimensions of all the cookies. You can see that they differ. Like I said, it's possible, and the customer wants to check how much they differ. And in case that some cookies are smaller, it means that there is a problem in the production process, and the maintenance team has to make some improvements. All right, so it's all. We've created entire application. Now we could create a formula and check whether all the dimensions are in the are in the specific range, create an human-machine interface, add a communication with external devices, and it's all. The application is ready, and you can use it on the production floor. So thank you very much for being with me here, and have a nice day. Bye.